So here I'm going to give you a couple of exercises on calculating the determinant of a 2x2 matrix. What I want you to do, read the questions, pause the video, have a go at them, and then come back and check your answer against the working I'm going to present to you here. So, here you go. So it's just two questions. First one, I've got two matrices there for you. I want you to calculate the determinants of them. And then the second one, I'm saying to you, for what value of A would the systems of equations below not have a solution? So I want you to determine that value. So pause the video and have a crack at those. So the first one, calculate the determinants of these two matrices here. So if I label the matrix A, so let's say A equals that, my determinant of A, so determinant of A, what I'm going to say is that that equals the determinant 2 minus 1, 1. And again, it's just following that same technique. So one diagonal, product of those numbers, take away product of the other diagonal. So I've got 2 times 1, take away negative 1 times 2. So I've got 2 minus, well this gives me minus 2. So minus minus becomes a plus. So it's 2 plus 2, which is 4. So again, if this matrix were to be used to represent a system of linear equations, I'd get a solution. Second one here, same set of steps. Let's call this B to avoid any confusion. So I could then say find, so the determinant of B is equal to determinant of negative 2 to negative 3 and 3. And again, it's the same set of steps. Two diagonals, take away the products from one another. So it's negative 2 times 3, take away negative 3 times 2. So that would be negative 2 times 3, so that's negative 6. Take away, well negative 3 times 2 is negative 6, so that would be negative 6 plus 6, so that would be equal to 0. So for this one, there would be no solution if this was a system of equations. Determinant is 0, so I wouldn't have a solution for that one there. Second question was, for what value of A would the system of equations below not have a solution? So the first thing we have to do is represent this system of equations in terms of matrices. So what I do is I rewrite it as 3x plus ay, and then 2x minus 6y equals 4, 5. And if I were to then write it, what I'd do is I'd take out the coefficients, remove the pluses and minuses, and then put my x and my y as a column matrix. So I'd have 3, a, 2, and negative 6 there. I'd have my x and my y, because if I had matrix multiplication and I did it here, I would skip back to the system of equations I've got. And that equals 4, 5. Now, for the system of equations to not have a solution, if I let A equal the matrix 3, A, 2, and negative 6, if I did the determinant of A, that would equal 0 for it to not have solutions. So what I then have to do is if I take the determinant of A, it's going to be the equivalent of the determinant of 3, A, 2, and negative 6. And again, nothing changes just because I've got an unknown, an A in there. Still follow the exact same steps. So I'd still get 3 times negative 6, take away 2 times A. But what I'm then able to do is say that for this to work and for me to get the answer that I'm after, that would have to equal 0. So 3 times negative 6, that's negative 18. That's then going to be take away 2a is equal to 0. So if I solve this equation, I'd get 2a is equal to negative 18. So a is equal to negative 9. So if I had that element, a being negative 9, what would happen is I would not get a solution to this system of equations. Any other value would be fine, but a cannot equal 9 if I want a solution in this case. It is a fairly straightforward thing to be able to do. Determinant of a 2x2 matrix is a fairly straightforward, simple calculation. You just have to remember the formula for it. And again, looking at that little trick with the two diagonals, taking away the products, that's a very quick and easy way to do it. 2 by 2 is fairly straightforward. Make sure you nail this skill, because if you look at 3 by 3 matrices, you have to use 2 by 2 matrix determinants in order to calculate the determinant of a 3 by 3 matrix. So you're going to be expanding on this skill. Make sure you've nailed this skill before you do anything else, because it is a vital one for you to be able to do.